Hi, I'm David Kais, and I run R for the rest of us. You may think of R as a tool for complex statistical analysis, but it's much more than that. From data visualization to efficient reporting to improving your workflow, R can do it all. On this podcast, I talk with people about how they use R in unique and creative ways. I'm joined today by Will Landau. Will is a statistician and software developer in the life sciences. He earned his PhD in statistics at Iowa State in 2016, and he specializes in Bayesian methods, high-performance computing, and reproducible workflows. Will is the creator of the Targets R package, a reproducible analysis pipeline tool, which became part of ROpenSci in early 2021. Will, welcome, and thanks for joining.
Glad to be here. Thanks for having me.
Well, I want to start out just by asking some kind of basic questions. I'm curious kind of how you first got into R.
Well, I got into R because at the time it was pretty much right in front of me. I was in undergrad in my third or fourth year of college, and I was just discovering how much I loved to code, and I was just getting into statistics. And that kind of gradually started to intersect when our homework assignments used R. And there was a mix of reactions. I mean, people come to statistics, I'm sure you know, from all kinds of backgrounds. And people come from economics, computer science, even a lot of other different backgrounds. Some people really love to code, and some people struggle with it a bit. I think that for me, it hit me right at the right time. And I loved it. I loved how the computational problems intersected with the statistical ones. And I wanted to carry that as a focus through, whatever I did after that. And in grad school at Iowa State, I got really lucky. There was just such a strong R community. There was a lot of people doing really cool things in visualization and package development. And professors Dai Cook and Heike Hoffman were there. To give you an idea, they were the mentors of Hadley when he was at Iowa State. And they kept that community going, and the grad students around me kept that community going. There was just a lot of collegiality, a lot of excitement around the stuff that we were doing in R. It was there were just a lot of positive vibes and interesting projects, and I couldn't really help but grow to like it every year that I used it. And now at work, it's I'm among colleagues who use R all the time. We're basically an R shop, and what I do falls under classical experimental design a lot of the times. So it's still a good fit for the job.
And I know you work, I should have mentioned this before, you work at Eli Lilly, and for obvious reasons, we can't talk about, the details of what you do. So I wonder if you could give me kind of an overview. I mean, you talked briefly about, some of the in broad strokes, the work that you do there, but I wonder if you could also talk about kind of the daily work that you do with R as well, especially on the kind of the open source side and what that looks like.
Sure. Well, there's two sides that I quite like with the open source work that I do. And one is statistical, and not all of the models that I develop or contribute to are available as open source packages, but some are. And there's this great collaboration that I'm part of. There's this ASA group called OpenStatsWare, and we have a work stream to implement a Bayesian MMRM. And we're developing this package. We're pooling all kinds of knowledge from across companies. And I've taken the lead on the implementation of this package. It's called BRMS MMRM. It's very much a group effort. And that's a model that comes up a lot in my line of work. It's this repeated measures model of experimental data. And it's non-competitive. It's used by so many of us that we just want to get a solid implementation that we all agree on. And that's been extremely rewarding. And with that package, we've we have a CRAN release or two, and we have done a lot of the interface work, and we're going to move on to the deeper statistical pieces of borrowing from historical data sources and stuff pretty soon. Um, and the other side of that is the infrastructure and the workflow tools that I work on, like targets, which we'll get into. These are tools just to make your life easier and just to manage the analyses and the analysis workflows that go into either developing a model like that or running really any kind of data analysis project. And so, I mean, there are things that I do that a lot of people may not be able to relate to, and like to be upfront about that. But we all face a common set of workflow problems, no matter what we're using to analyze our data, whether it's a Bayesian model or a machine learning method, or just some data transformation and ETL.
Yeah. Yeah. And I'll say, I mean, speaking for myself, hearing you talk about like the Bayesian work that you do, that's not something that I am even familiar with. I wouldn't even know where to start with that. But, I know, as I was mentioning to you before we started, targets as a package is something I've heard about and has intrigued me, but is not something that I've ever had the opportunity, or I guess I've chosen not to take the opportunity to use it. So, um, I'm curious if you could kind of, at a very high level, give me an overview of what targets is and talk about where the idea for it originally came from.
Great. So targets is a what I'd call a reproducible analysis pipeline tool. And so you have in a typical project some data sets that you want to analyze, and you'll produce model objects for the fitted models, and then you'll summarize those models and or maybe you're not doing modeling. Maybe you start from the data sets and you want to run some visualizations to explore the data to see what a scatter plot of one variable looks like against another. And maybe you want to summarize those results in a bunch of downstream reports in R Markdown or Quarto. There are these depths of flow in a data analysis project. And if we think of a data analysis as a project, that's when it becomes big enough in that sense. That's where targets comes in, and that's where it starts to help. And hopefully when we get into an example, we can start to think about, well, what kinds of projects targets is originally intended for. But the idea came when I needed a package like that to do my dissertation work in grad school. That's the first time I started to want a tool like targets. I was developing this large Bayesian model for this agronomy problem, and on top of all the writing and all of the model development, I needed to run this model on some pretty big data sets as far as genomics was concerned. And each time that I started to run the model, I had to wait 3 or 4 hours for it to complete. And I had a bunch of those analyses. And then meanwhile, I had these other moving parts, like the dissertation that I was writing, that depended on those results. And it was all a lot to keep track of. And the runtime of these models blocked me from updating sort of one part of the project, and I had to focus on another. It was just very hard to wrap my head around it all, and to go about my day putting together something that ended up being a dissertation. And my advisor, Jared Nemi, watched me struggle through all this the whole time. And he mentioned to me that I should be using a tool called Make to organize and wrap my head around this stuff. I was a bit too far into the project to transition to a thing like that at the time. But then when that was all wrapped up and I defended, then I immediately went to start saying, okay, how do I make this easier for other grad students like me? And how do I make this easier for my future self? And how do I make this easier for anybody who's developing any kind of project, whether whether it's like a dissertation, or whether it's something even a little bit more lightweight, or something that maybe has less of a runtime burden, but just has hundreds of artifacts that you want to produce, like in an ETL workflow. And that's when I started searching for existing tools. There's this developer, scientist, statistician by the name of Rich Fitzjohn, who had developed something that was almost what I was looking for. It was a package called Remake that he had developed between 2014 and 2016. And that package is like the Make tool, except designed completely for R. And the concepts that he introduced there just completely blew my mind. The way that he took something that was, it's usually language agnostic, and made it completely focused on R and extremely friendly. And the reason that I originally got into developing pipeline toolkits was he had moved on to other things, that he was no longer at a certain point interested in developing Remake. And so at that point, I created a project called Drake, which was kind of like Remake, but initially it attempted to pursue a greater degree of scale in a couple of ways. And that was when I was really first getting my start as an R package developer. And that was a journey. I learned an absolute ton from it. But Drake got to the point where I was faced with the hard limitations of my original design choices. And so up to a certain point, it became time to take the lessons that I learned to developing Drake and to start something completely new. And then that became Targets, which I started to develop in 2020. And I was secretly working on it on nights and weekends for about 6 months. And then I open sourced it and released it to ROpenSci. And the rest, as they say, is recent history.
Yeah, that's great. So, from my kind of naive understanding, so I think about, for example, the types of projects that we do, which don't actually involve any modeling, but typically what it involves is taking some raw data. We usually have an R script file where we take the raw data, do cleaning, transformation on it. Then we typically save that as usually as an RDS file, and then we do a lot of reporting, so a lot of parameterized reporting, that type of thing. So then our Markdown or Quarto files read in that kind of cleaned, RDS file, and use that for the reporting. And we've developed this a structure like, we basically follow the structure that our packages use, where we'll put our raw data in a folder called data-raw, and then our clean data goes just in the data folder. But what it sounds like you're saying is essentially Targets is kind of a formalization of some of the processes that we have kind of informally put together, where, for example, we don't, maybe it takes a while to run the code to clean your data. And, the way we deal with that is we run it once and save it as an RDS file. But with Targets, you could set it up so that it kind of always knows, how have we run the most, the code, the kind of cleaning transformation code, is that up to date? And then if that code changes, it'll kind of like rerun it, right? And so it helps to, again, I guess it's really like formalizing that process of making sure that it both speeds up your kind of runtime, but then also make sure that everything is up to date. Am I accurately understanding the kind of
Yeah, that's a
promise
great
of Target at a
description.
high level?
And I like your use of the word transformation in particular, because this is where we start to think about a project-oriented workflow like the one that you described with working with data and generating reports as a series of transformations. You're transforming those data sets into reports, or maybe you're transforming those data sets into human readable summaries and then transforming those human readable summaries into those reports. It's this mapping it's a really useful aspect of this whole process to think about and to be pedantic about. And that's to think about which one of those transformations, what is exactly going on in each one of those transformations, and what are the set of inputs that you need, and what is the one output that this transformation produces in each case. And I think that's kind of how targets makes this whole process a bit more pedantic. And then the process of skipping a step that's already up to date and then only running it if the upstream code or dependencies changed. For somebody who's running these extreme kinds of Bayesian or machine learning models, it's a really critical time save. And it's the kind of problem that you don't know you're going to have until you're faced with a kind of analysis that takes forever to run and that you might have to stop in the middle. But there's something for everyone in that it's, even if you're just churning away at a couple of data sets and producing some reports. I mean, you might have a couple of those, or you might have a few hundred data sets and a few hundred reports. And to be able to see right in front of you that everything is up to date it's vouching for the reproducibility of the project in the most from first principles sense that I can really think of it. It's saying that if you were to reproduce or recreate this analysis from scratch, here are the results that you get, and here's evidence that is synchronized. And that's a kind of reproducibility that was missing, I think, for a long time. And it complements the kind of reproducibility that you find in being able to describe in your own words exactly what's going on, let's say, inside an R Markdown or a Quarto report for the analysis.
Yeah, that makes sense. Well, I have a bunch of questions about targets, but I actually think what would be most useful at this point is to have you give us a brief demo, and then I can ask those questions. So I'll let you, if you just want to put your screen up.
Certainly.
And then we can watch that.
So this example comes from this targets 4 minutes repository that I have on GitHub. And it comes with a video, and it comes with a POSIT cloud workspace where users can log in and access the same workflow without having to install R or any packages on their machine. The code that I'm showing right now is actually a bit of a modification. So I took out the comments, so this screen is a bit less busy than what you'll see in the hosted version. And then I added a Quarto report at the very end. And just to start from the beginning, this is a special kind of file that you see in front of us that'll get to first. It'll get to eventually. But what I'd like to do is start with the functions that go into this data analysis project, because from our discussion about the word transformation and how it applies to data analysis, the functions in R are just such a natural building block to describe transformations, especially pure ones where they don't write files in and of themselves, but they return an object at the end that really has everything that you might care about in an analysis. So usually these functions I found either produce data sets, or they fit models, or they create human readable summaries, or they generate some visualizations or reports. And I think if you're going from one of those types of artifacts to another one of those types of artifacts, a function is a really natural tool to describe that. And it's not a tool that's often used, but once you get used to describing the work that you're doing in functions, even if it seems overly pedantic at first, it's hard to stop once you get going. Miles McBain has an excellent post that he called a function-based diet in programming. And he talks about Target's predecessor, Drake, but he also makes a really compelling case that this is an approach that fits a lot of data analysis workflows. So I'll go right ahead and I'll load.
And actually, Will, can I just ask you, like, if you're starting a new project and you're like, okay, I'm going to use targets for this, how do you just start even before you get to this point? What would that look like? Because obviously you have some stuff set up here, which is great. But I'm thinking, okay, I'm starting a new project, and I'm like, yes, this time I'm going to try out targets. How does that work?
So I think to identify the steps in the workflow, just conceptually, what data sets do I start with? What summaries do I want to create of those data sets? And what reports do I want to produce? That's something that would help to get really clear on. And then to think about, okay, what is transforming into what? So if I have a data set and I have a model, what are all the steps of going from one artifact to another artifact? And that's where the functions come in. So before you even get started with targets, I would do what you do, which is to write a bunch of standalone R code and put it in an R folder of your project and express that in terms of the functions that describe the data analysis. And to develop and test those functions on your own, play around with them, see what works on small test cases. I found that to be a really useful place to start before putting it into a targets pipeline.
So people will typically then start by like having a project that they've done in a non-targets workflow, and then kind of think about applying targets to that. Is that right?
Yes and no. I mean, for some kinds of projects that don't really make explicit use of custom functions, the transition can be really hard. But if you start a project that you will want to build a targets pipeline into, and if you've written these custom functions from the beginning, then it becomes much easier. And when you add targets, it doesn't need to be the kind of project where you've already put all those pieces together. You can start with just a few small functions that you experiment with yourself. And once you get an idea that they're working okay in very small test cases, then it's a good point to put it in the targets pipeline.
Okay, that makes sense. So I'll let you go ahead then and continue with your demo.
Sure. So just to demonstrate what I'm doing with these functions, just going to source them into the session real quick. And I'm going to say that we're going to start with the data file. This is just the air quality data set in base R. And if I were to think about just developing and testing these functions, I might sort of define some example data. And if I were to just walk through the code for a scaled down version of this pipeline, I might say, okay, let's transform the file into this data object that we're going to use. So data, and I use the get data function, which I wrote, and the data is going to be this air quality data set from base R. And let's say I want to fit just an ordinary least squares regression model to the data. I'd have something like model just to get used to testing the functions, experimenting around with them, and getting a feel for how how these transformations that we've created are used. So you might say that let's fit the model to the data, and sure enough, we get the model coefficients for fitted model and so on. So assuming I've done all this, which is completely outside of targets and is a good practice for a data analysis workflow anyway, we could then move on to targets. And what that's going to involve is taking these functions, these reusable building blocks, this shorthand for the different tasks of the analysis, and we'll turn that into the actual analysis. And that's where this underscore targets file comes from. And you don't need to write it from scratch. There's this function targets called use targets that creates one. I'm not gonna run now, but if I were to run use targets, it would create one of these files if it doesn't already exist, and it would be heavily commented and would provide directions for what options to set and et cetera, et cetera. But this targets script looks and feels like you are starting a session and actually running all of the tasks, and with an emphasis on the setup part. So when you begin an analysis that's, whether it's inside targets or outside targets, you start by loading some packages and setting some options, loading some reusable functions that you've defined. and then going and doing your work. And that's why this targets file is the way it is. So I start by loading some packages that I'm going to need to define the pipeline. I'm going to set some options, and this packages option is the list of packages that the tasks in the pipeline are going to need when they eventually run.
Then instead of running like library dplyr or library ggplot2, library readr, you run tar option set, which essentially does that same thing. Is that right?
Yeah, the packages option in tar option set registers the packages that are going to load when they need to. So they're not going to load right away, but in the actual steps of the pipeline, they're going to be
Gotcha.
useful for performing the whatever the target
because I
needs to
saw,
do.
for example, in the functions.r file, you don't actually have, you don't load your packages there. So it sounds like by setting it as part of your pipeline, it will then use those packages as necessary, including in those functions. Is that accurate?
Yeah, exactly.
Okay.
And the function script is loaded actually in the next step in this tar source function. What this does is it runs all the R code scripts that are inside this R folder in the file system of the project. And it has the effect of loading all those functions into the environment where this script is running. And if those scripts actually had the analysis, it would run that. But standard practice is to just have the functions themselves. And so it's actually really quick. This is all part of populating your workspace. And then where this starts to differ from a regular analysis is in line 10 to the very end. And these are a list of what's called target objects. And you have this call to the tar target function for each one. And each one of these is a step in the analysis. It's a single task that is going to be run in the pipeline when you run it. And so it'll have a name, it'll have a command, which is just an R expression that's going to run when the target runs. You can have a bunch of other options. In the development version of targets, you can even add a human readable description. This is a feature that's not quite in the current release yet, but is going to be in the next one. Likewise for other steps in the pipeline. And so these expressions like get data on file, they're not going to be run just yet when you run this list. These are quoted and they're going to be run later. But instead of just saying get data in the R console like we did before, we're saying, okay, this is a task that's going to run later when everything is ready to run. And this is a really pedantic way of laying out all the steps in the pipeline, all of the inputs and all the outputs. And the inputs are what you would read as the function arguments or the global variables in the expression here. And the output is going to look and feel like the object that you've given in the name.
I was just going to say, it sounds like starting on line 10, you're not like running the code, but you're laying out, these are the steps that we're going to go through. So first, the tar option set says these are the packages that we're going to need for our project. Then tar source runs all the code in the R folder, which has typically your functions. Then you define all of your steps. And I assume we'll get to this in a second, but down below, there's going to be a function or something that will actually like run the pipeline. Is that an overall accurate summary of how this works?
Exactly.
Okay,
It's
cool.
a lot of table setting, and all of that table setting isn't always apparent right away, but it does pay off. And
Okay.
I'm going to describe the ways that it pays off, well, right now. So one of the things that this allows you to do, if you're really pedantic about setting up the pipeline, is you can call functions to inspect the pipeline. So for example, you could say tar glimpse is a function, and one of the small handful of views that targets gives you to let you see the dependency graph of the pipeline. And here it is. Let me move things around just so it's easier to see. So what this is like I said, it's a dependency graph. It's a visualization of the natural left to right flow of the pipeline. It's going to show you what is going to happen when you run it. So in an analysis pipeline where you have, let's say, hundreds of steps where you import data sets and write reports, and you have steps that are even downstream of that, it's helpful to have a tool like this to wrap your head around what you're doing, because sometimes code bases can get out of hand, and a visualization like this can kind of rein it in. So,
Yeah.
and no matter what you have here, and no matter what you do to list the order of these steps, you're going to get this dependency graph that shows the left to right flow of what's going to happen. So we need to track the input file first, then we're going to load the input file, we're going to model it, and we're going to take the data and the model. And with these arrows, it's showing you that that's going to be incorporated into the plot, and the plot and the model are going to the report. And this graph is going to look the same no matter how you order things in the pipeline. So I could put the file down here below the data. And if I rerun this, it's going to give us the same graph. And the reason it does that is because there's this behind the scenes magic called static code analysis. And what it does is it parses the expressions that you give in the command, and it looks at the global variables that it gives you. And so if I look at this expression, get data on the object file, where does the object file come from? Either it's a global object that you've defined up here, or it's the name of another target. And that's how this pipeline knows that the file depends on the data. And this is something I learned from Rich Fitzjohn, that we can use static code analysis to construct one of these graphs. And it's going to help the pipeline later on run the correct targets in the correct order.
Yeah, that's great. I mean, that's so helpful to be able to see it. And honestly, seeing that right there, it's like, oh yeah, that is basically what we do in our consulting work. And we know, because we do it over and over and over, but having that, something like that you can actually see is really helpful, just to keep everyone on the same page as well.
Yeah, to keep everyone who's working on the same page, it's helpful. I'm glad you brought it up, because it's helpful for collaboration. It's helpful to document the workflow if you're sharing it with your colleagues. And it's helpful for your future self if you work on the project for a while and then leave for 6 months and then come back to it later. Sometimes it's hard to look at this code and wonder what you did. But I mean, with the dependency graph and the report at the end, I've gotten myself out of that jam in about 10 minutes, where it would have taken a few hours or even longer just to remember what I did if I want to update the project without breaking it.
Yeah. So how do you then run everything, say to import the data, to do the modeling, the plots, the reporting? How does that happen?
There is a function called tar make. And what it does is, the tar make is the thing, and tar glimpse as well, but tar make in particular is the thing that runs this report. And it expects the last object returned by this script to be this list of target objects. And that's what it reads and parses to understand what to do. And then it goes ahead and runs the correct targets in the correct order. Okay. And right now it's spinning up the background reproducible process to isolate the pipeline environment from everything else. And it's running the file first, and then the data, and then the model, and so on. And this is what all the table setting led up to at this point. And I think it goes to show how important that table setting is, that we've got about 45 minutes into this podcast. And this is the first time I'm running the pipeline, and it's a lot of upfront investment at first until it becomes habit, but the payoff is tremendous. And then the table setting becomes a natural part of the development process once you get used to it.
And do you typically have that tar make within that targets.r file, or do you just run that in the console?
You can run it in the console. It's important that it exists separately from targets.r. So the script is actually instructions for tar make. And if I were to put it somewhere in here, it would call itself recursively in infinite loop. And I know I shortcutted to run parts of this code a few minutes ago interactively, but this is really for not for interactive use. This is for a function like tar make or tar glimpse.
Right.
And So tar make, you can run it in your console. In the most recent version of targets, you can actually run it as an RStudio job as well. So borrowing from the interface of Quarto, you can say as job equal to true. And what this will do is it'll trigger a background job. And when it emits output, it'll tell you what each of the results of processing the targets are. So because I've already run the pipeline and I haven't changed anything since I ran it last, it skips everything and it takes far less time to run. And meanwhile, this whole time while the job is running, your Arc console is completely free to do whatever else you need to do.
Well, yeah, you can see there it was, 21 seconds the first time, but then the second time it was like half of a second, because I don't know what the right terminology is. It's cached everything essentially, so that it doesn't have to run everything again. It can use what it's already done.
Exactly. And there's even a little bit of time savings is noticeable just to make your life easier. It doesn't have to be several hours. It can be just a few seconds or a few minutes. And the more targets you have, the more it adds up too. And so anything big or small can really benefit from the peace of mind that gives you to be able to flow through your work a lot more smoothly.
Yeah, that makes sense. Was there anything else in terms of the code walkthrough that you wanted to show before I ask you some kind of broader questions about targets?
I'll just mention that this business of a target being up to date or not, there are a lot more functions in targets that allow you to inspect the state of the workflow and the progress of the workflow. Documentation website is a long list of utilities for that. And even in the dependency graphs, that information is color coded into functions like tar viz network. Whereas we had a tar glimpse here with just the targets in the pipeline all colored gray. When this tar viz network graph shows the nodes will be color coded based on whether they're up to date or not. And that includes the targets in the pipeline and the functions here that you see on the left as triangles.
So in other words, if you see something in that viz network there that's not up to date, you would want to run tar make again, which would bring it up to date. Is that right?
Right.
Cool. Well, this is great. This is really helpful. Let me ask you some kind of broader questions now. So I'm curious, like in your mind, how complex does a project need to be to benefit from using targets?
That's a hard question because there really isn't a hard and fast rule, and it can depend on personal preference. But I would say anything even a little bit complicated, or even a pipeline with 4 or 5 steps, or even 3 or 4 computationally intense steps is worth doing in targets. Once you experience the time savings and I didn't even get to the features in targets that abstract away files as R objects. You mentioned that it's common to manually save the output data as an RDS file and then read it back later. In targets, there are more convenient functions to access data in that cache or that data store, and that in itself is a convenience that's hard to move away from, even for really small workflows once you've experienced it. And projects can also be complex in a bunch of different ways. So sometimes the computation time is a burden. Sometimes you just have a lot of data objects to output and a lot of downstream tasks that read in those data objects, and targets can smooth things out in either one of those cases.
Yeah, I mean, I think about for the work that we do, it'd probably be less on the kind of runtime issues. It's not that it's going to take a huge amount of time, although there are some cases where that happens, but it's more about making sure everything is up to date. For example, like we create some reports and then the client says, oh yeah, here's some new data. Well, the way we do it right now, we have to make sure manually that someone goes in and reruns the data cleaning and importing code, transformation code, so that it spits out that new RDS file, so that when we generate the reports again, it's using the up-to-date data. it seems like, using targets would make it so that every time we run tar make, it will just check, okay, is the data is everything up to date, so that before it generates those reports, it just automatically runs that code. So I can definitely see the benefit of it.
Yeah, it's one of those things where you don't realize how much mental bookkeeping you're doing just to
Yeah,
remember the state of the project. It's much easier to have a tool automatically tell you. And it's
right.
hard to move away from that once you've experienced it.
Yeah, that absolutely makes sense, because a lot of times what we have to do too is then we have to explain to the client how everything works, because they, in some cases, will actually take over the project and then run it themselves. And it's only when we're actually sitting down and going through, okay, first you do this, then you do that. We'll have like a really long README sometimes, and it seems like in some ways targets is a really long README in code, in a way that can facilitate people continuing to run the code in a way that is efficient and hopefully makes more sense to them than the long READMEs that we give them.
Yeah, that's a great point. And I've seen users of targets insert dependency graph visualizations in their READMEs. So there's this JavaScript library called mermaid.js that produces really nice static graphs. And there's this tar mermaid function in targets to produce one of those visualizations of the dependency graph, but in a static format. And it's possible to embed that into an R Markdown document and share that. And with the description field of each target that TJ Marr and Noam Ross nudged me to implement in targets, I think that could be even more powerful for communicating how the pipeline is set up for somebody else, either who's just consuming the results or sharing in the development.
Yeah, that makes sense. Well, I have a couple last questions for you. First, I've heard people describe targets as kind of the equivalent of the efficiency, switching to targets as the efficiency gains that you get if you switch from an R script-based workflow to using something like R Markdown or Quarto. I'm curious if that comparison resonates with you.
It does. And I remember when I discovered that I could use R Markdown to do homework assignments in grad school. And I just remember how much nicer it was than having an R script over here and maybe some comments on the code, and then my description in my own words in prose in another place to show the other parts of my work and my thought process. And to have those woven together in a lot of situations was just really nice. And it solved a problem that I didn't know I had until the problem was actually solved.
Hmm.
And targets, I think, is similar. Not everybody is immediately faced with these crushingly long runtimes. And so maybe the friction is just enough to fly under the radar, but it's still a problem that you may not know you have until it's actually solved. And although those are different problems, they're hidden in similar ways.
Yeah, that makes sense. Great. Well, one last question. I'm curious what changes you kind of anticipate making to targets in the future. I know you talked about adding the description field. Are there other things you're thinking about as you move forward with targets?
So in general, most of targets, I think, is in a really good spot. I think that there will always be bug fixes and little features and just general maintenance to do. And that's just part of every actively maintained package. And I'm in it for the long haul. Over the past year, I've focused most of the development on trying to make targets a viable cloud computing pipeline tool. And that kind of work has been really important to me and my colleagues. That's kind of where the project is at the moment.
Great. Well, Will, thank you very much. This has been really useful. It's given me a lot to think about. It's inspired me to think about potentially trying out targets. So thank you again for taking the time to chat. I really appreciate it.
Glad to be here. Thanks for having me on.
That's it for today's episode. I hope you learned something new about how you can use R. Do you know anyone else who might be interested in this episode? Please share it with them. If you're interested in learning R, check out R for the Rest of Us. We've got courses to help you no matter whether you're just starting out with R or you've got years of experience. Do you work for an organization that needs help communicating effectively with data? Check out our consulting services at rfortherestofus.com/consulting. We work with clients to make high-quality data visualization, beautiful reports made entirely with R, interactive maps, and much, much more. And before we go, one last request. Do you know anyone who's using R in a unique and creative way? We're always looking for new guests for the R for the Rest of Us podcast. If you know someone who would be a good guest, please email me at david@rfortherestofus.com. Thanks for listening, and we'll see you next time.